Great to be here. I'm the mathematician. So I'm working with students on math and teacher education in Bergen. And I'm quite new to this drama thing, so this week has been really exciting. I told them back home in Norway I want to change subject. I'm going to be a drama teacher after this. I forgot mathematics. Yeah, can you sit there?
Yes, I will.
Yeah, okay. What I will talk about is how we are changing the way we are looking at mathematics. It's not that only, I will have focus on how we do it in Norway, because we are changing our curriculum next year. But this is nothing that we found up in Norway, waking up in one morning, now we have to change our system. This is international trends, and I want to start to show how this international trends has changed the last maybe 20 years. So what we see is that we have more focus on to see the whole child, to see the whole students. Not only you are going to learn math, this is the way we do it, but we see this as a whole. And we have a focus on this deeper learning, that they need to have to learn. What they learn in school is a competence that they can use in their real life. So, and this whole, look at the whole child, is like we have this interpersonal, the way they need to work with communication, work to cooperate with other students, with teachers, and we have this intrapersonal, that you believe in yourself, that you see you have your ground mindset, that they can always learn more, that I have the ability to learn more, and the teacher sees me as a person that is in a process of learning more. Not like, okay, I know your family, I know what you can do in math, I don't have any expectations about your learning. This is what we want to fight against. We want to see that every child can learn a bit more next day than they did the day before. And the child needs to know it. So this is really important in learning. And we can, as a math teacher, we cannot separate from that. We need to see the whole child. And also this cognitive, this deep content knowledge. And we want them to be critical. We want them to say, well, what's on Facebook now? Is that the real truth or is it not the real truth? They need competence to look into this real world complex thing and have a critical mind on it. And as a math teacher, we have to give them that competence. And also this problem solving skills, because we don't know, the world is changing. And we need something else than we did before. Like drilling or memorizing the formula is not that necessary anymore, because it's just a Google touch away. You can find it, but what is important is that they know what to look for. So as a math teacher, you need to give them this competence as well. And drama, they connect all of this. As a tool, we can use drama to accomplish a lot of these through in our math teaching. Yeah. So if we go to the World Health Organization, they talk about life skills, and you also did that. And we can compare it what's to the learning and how we want the child to learn. We can see it's the same. There's the social skills, it's the thinking skills, which is problem solving, decision making, creativity, and critical thinking. And also the emotional skills. So it's the same. So this is what we build our new curriculum on. But we are not alone, you can tell. If we go to Finland, I don't know if you know about Finland, but Finland has a big star in the international math community because they do it so well on TIMSS and PISA, these international math contests. And and as in Norway, it's our neighbors, we always go to Finland. What are they doing there that we are not doing? But they have also changed their curriculum. And what they are changing now is, they say, well, the new Finnish curriculum emphasize the joy of learning. Look at that. They want the children to have an acting role. They They want the children, the learning should provide positive emotional experiences, emphasis on the interaction between the children and creative activities to improve learning. And what they want to go away from is that there will be a change in the traditional format where students is passively sitting in front of the teacher, listen to a lesson and wait for to be asked. They will have a change. We need active students that think, that really enjoy it. They want to fight this. I have a big fear for math, because I never know the answer when the teacher asks. They want them to be active, like we did this week. And I also stayed 1 year in Asia, in Singapore, because they also have these top results on this in math competitions. And I wonder, what are they doing that we are not doing? And they said, what is the key business of doing mathematics today and in the future? Is it to memorize, or is it to think? And they are really emphasizes, we need the students to think. Deeper learning is so important. This memorizing methodology in math, we should leave it forever. So they say that, yes, in the 21st century approaches, country needs citizens who is prepared to participate in brain power. That's what we need. Not robots that are taught to think this way. And math is a tool for accomplish this. So this was the background for our new curriculum in Norway. We want the teaching in math to be relevant. Students should see that, why am I learning this? Is a reason. We want the students, because the world is changing, the new technology is changing, they need another competence than they did before. There will be a better connection between the subjects. So drama, language, math, it should be a whole for the child. Not like, no, we have math and it's separate for everything else. So like what we did here with the drama, using it. So I'm thinking today, when we are showing what we are doing, have done, as a math teacher, don't think, oh, I will not have time for this, will take all my math lessons for this week. You have to cooperate with the language teacher, with the social skills teacher, so you have to make this together, because it's combined. And, of course, what we have done in Norway, to promote and to have this deeper learning, we cannot fill the curriculum with so many subjects or so many themes in math that it used to be. Because then you come in this squeeze, like, I have no time, I have to do this, I have to do this. So what we have done is take away some of the, and more emphasis, like fraction on the 5th year, and maybe we are not doing the fraction on the 4th year. So we are kind of making it more heavily on some of the grades and taking away from others. Okay? So what is deeper learning? We can take both. Well, it's a bit, deeper learning, it's about the ability to analyze, to think critical, to be thinking. And what we want is to construct learning that's lost. Not that you can memorize it when you need it, but as you can use it. So the central point is application. That means the capacity to apply knowledge and skills to cope with the challenges and solve tasks. That's the mean. Okay? I want to give you some example. This is a researcher called Richard Scan. How many have heard about Richard Scan? No. Oh, you're the only one. She's from Norway.
Another one.
Yeah, great. Because the first time I heard about him was when I had my stay in Singapore. Because their curriculum, in the beginning, it stands our curriculum is based on Richard Scamm's theory. And what's interesting with Richard Scamm, he says it's two ways to learn mathematics, or to learn. One way, he says, is an instrumental way of learning. That means that only the surface structure on the brain is in play. It's the center of memorization. Like, you do what the teacher is telling you, and you memorize and memorize until it's there. Okay? The other way, says Scamm, is by deeper structure. And he calls this relational teaching and learning. And then, as you can see, the whole brain is in play. And one of my students, she said that when I gave her problem-solving task, she said, "Oh, my head gets so warm every time you give me this task." And that's deeper learning. What's happening when you are in this process of thinking? Then, once again, I think one more, yeah. But you see, it starts to build what we call cognitive schema. It's built like, okay, I know about this before, and this is something I can add on to my pre-knowledge. And that's learning. This is learning. The other one is memorization, and you cannot use it. And if we go inside the brain that's learned by memorization, you will look at this. Well, it's chaotic. Everything is there, but it's not systematic. It's just put in, put in, put in. And if you have a child that has learned by this, the next time he will meet it, he will not find it. Because I can't remember, I heard about fraction, yeah, well I know, maybe I heard about it, but what is it? But what we are gaining, what we want them to, is that the brain looks like this. Look at this. It's so, when you are approaching a new thing, a problem solving, it's much more easier to find out what tool do I need, what mathematics do I need to solve this. And to get this, we need to change the way we teach math, as easy as it is. And to accomplish this, the Norway new curriculum emphasizes on these 5 core elements. We want them to work with representation and communication. We want them to inquire and have problem solving. We want them to meet mathematics by modeling and application. We want them to work with abstraction and generalization and reasoning and argumentation. If I have time, I will give you a short glimpse on what this means. So let's start with representation and communication. Well, the student should develop a mathematical language through conversation, reasoning, and reflection. We want them to switch between appropriate representations such as symbols, figures, drawings, graphing, tables, diagram, verbal expression, concrete material hands-on, and drama. And to understand the relationship between these representations, they need to work with them alternatively. So let me show you some examples. Freudenthal Institute in Netherlands is one of the main research centers in Europe working with this representation and make the math useful and understandable for the children. They use the iceberg metaphor. You know the iceberg, as we in Norway, we are really familiar with this, but iceberg, you have 20% of what you can see is over the sea and 90% is under the sea. Okay, what they say is when you are learning mathematics, the symbols, the numbers, the formulas is the 10% over the experience. The drama, what we did here, what they connected to the real world, that they can use money, that they can count, that they can draw, all these things, that's not that easy to see, but it's essential for the understanding. So if the children don't have the 90% under, they will never learn mathematics with deeper understanding. It's not possible. So take another, look at this mathematical task. What level do you think this is? When do they work with this type of mathematics? Sixth year. In Norway, the teacher will probably say the 9th year, because it's 4 unknown, you see? Yes, and it's one task. Well, I'm going to tell you something. Yesterday, I sat with a group of 10 years and 11 years children, and they were solving this problem as fast as you can even imagine. But the task was a bit different, but the same. The task was like this. Can you see what the representation did with the task? The cognitive level of the task was lower at 1 second. The 10 years were not able, of course, to solve the first one. But this one, they took at once. They were so exciting. They were standing all of on the chair, and oh, this is so exciting. So this is a good example of how we can work with representation. And I think I have a task for you. We still have time. Can I have time? Okay. Okay, I will give you a task. Are we ready? Yeah. This is from a textbook in Norway from the 5th year. Okay. This is how it goes. And you're going to find out how much some children have saved of money. First, Anna and Thea and Philip save money for their vacation. What we know is that Anna has saved 3 times as much as Philip. We know that Thea has saved half as much as Anna. And we know that Thea has saved €75 more than Philip. And that's the information you will get. Now you will be able to calculate and find out how much has each of the persons saved. Off you go. I will give you 2 minutes because this is 5th grade and you are teachers. 3 minutes. 3 minutes to solve it. This one we can use in a drama session. This is hand calculation.
Χρησιμοποιήστε τα και μπορείτε να ανοίξετε εδώ, κοιτάξτε, είναι το τραπεζάκι, εντάξει, και μετά το κατεβάζετε πλέον. Ωραία, με την άρεσή σας. Έχουμε ακόμα 1/4 για την κυρία Μόνα, γιατί είμαστε μπροστά 15 λεπτά, τα καταφέραμε. Αντί να είμαστε πίσω στο πρόγραμμα, είμαστε πίσω. I tell them to use this.
Yeah.
Make comfortable yourself. Because if you press them, you know.
Oh yeah, the math fear. I know.
Make them the fear go away.
Yeah?
We have 1/4 to Mona more.
Well, it doesn't matter. You don't have to calculate it. But is it somebody who has the answer? Yeah, 1 already. 2, 3, and if I ask how did you do it? Did you use algebra? Yeah, of course. It's a math teacher. Okay?
Mona?
Yeah. But the 5th grade students in Norway, they don't know algebra. They do know pre-algebra, but they are not able to translate this task to unknown with X and E and that kind. So how do they solve it? Well, they solve it, and for you that's here now, that don't have the answer and are really confused how to find it and feel that they miss it's missing some information here. Somebody feel that? Yeah. Yeah, I know. But it's possible without this information. Well, I will give you an euphoric, is that an English word? Euphoric? Euphoric experience? A great experience. Make it simple. A great experience. Follow. This is how the Norwegian students will do it. They will say, okay, it's 3 persons here, I need to sort the information. Then Philip has saved some money that I don't know, but I don't care in the beginning. I said, okay, I draw a box that shows how much Philip has saved. So this is his money, but I don't know yet. And then it's Anna. What was the information about Anna? She had saved 3 times as much as Philip. Okay, if Philip had 1 box, she needs 3 boxes. Okay. And then it's Thea. She has saved half of what Anna has. So she has 1 box and a half. Okay, this is a drawing of what is in the text. But then there were a number there. Is it possible to place that somewhere? If you look at the drawing, this €75, where can we place it in the drawing? Thea has saved €75 more than Philip. Agree on that? Yeah, so where is it? It's in the half. Okay, so if this is a half box is worth 75, well, the whole box must be 150. And the solution is there in the drawing. In another representation, X and E. You see? This is math. You use your brain to figure it out. You don't thinking, how do I solve this? Is this a multiplication or is it division? Or what did the teacher say? You don't think, what did the teacher think? You think the way you think. What is the way to solve this? We want the students to have creative ways of solving it, different ways. Okay. Modeling and applications. Well, it's about, again, Kubidrona. It's something that's close to them from their daily life. And we want them to use this to make mathematics, to see the connection of the world and how they can use it. How many of you, as our math teachers here, have had questions for the students? What on earth are we doing with algebra? When do we need algebra? We all experimented. And we said, you need it for the high school, you need it for university. Well, really motivating answer. Yeah, I'm not going there, I'm going to be an actress, you know, so I don't need algebra. We need to show them how these things are connected. So the students should translate into mathematical language. We should train them to see the world and translate it into mathematics. They should use mathematical models to interpret solutions. Could this be right? Or could it be another solution? And consider the scope and the limitation of a model. This is important. This is critical thinking. This is important for the new world with technology and the competences they need there. And we are also using programming to explore mathematical modeling. That starts from the 5th grade in Norway. Okay? And then we have abstractions and generalization. Well, and immediately we think, oh, that's high school, that's secondary, that's gymnasium. No! That's 1st grade or kindergarten. This is my grandson when he was 5. Look at him. He's doing real algebra. Can you see? And he did it all by himself, and I was so excited. Look at it. He's building pattern. But what we need to know to generalization and abstraction is to explore pattern, to generalize their context, to develop algebraic thinking. And what that's all about is use real things, like Elias did. He built pattern. And then we can draw the real things, but there's a really strong connection, you see, from the real thing to the drawing. But we don't, in mathematics, we don't use too much time on the second level. We really want to go to the third level. That's an abstract model. So you don't have to draw all the frogs and all the girls and all the trees. You can make circles and crosses and make it simple. That's the way, that's why we have mathematics. We have a real complex world. We need something to simplify it. And that's the mathematics too. And then we are on the abstraction, on the iceberg tip, 10% over. Well, what the new colloquium in Norway says is that we have to spend time on the 3 first levels to really to let the children reach the last level with understanding. So we need to spend time, especially on the second last one, the abstract mode, the representation from numbers. So it's about, you can just paint on a. So this is how we work on the first grade or second grade. This is pre-algebra. Let them know what could be under the cup. And some of the solution is one answer, and they have to argument and communicate why. And some of the examples, there are several solutions, but what we are interested in is not the right answer. We are interested in the thinking. Why should it be this way? How can it not be in the other way? And the 6-year-old children, they are sitting there doing real mathematics and argumentation. But it has a representation. The numbers are not important here in this round. This is the thinking. And inquiry and problem solving. It should be from the children's heart. We should find problems that's really near to them. And I'm really looking forward to show you how we work these days with the context of a story and how we can connect it to the math. And the really complex math they did afterwards. Because they are solving not a math problem, but a contextual problem. Okay, so in this element, core element, the student should also here look for pattern and fun relationships. They should, and we should place more emphasis on the strategies and the process than on the product. As a math teacher, do you know what the first thing I said to my students is the answer is the least interesting thing in this classroom. The answer is not interested. I'm interested in your thinking and how you work to find your way out of the problem. Okay. And I have really strong support here. Yeah. This is a wise man who didn't like the school very much, and he was not seen as a specially gifted child at school. You know the story of Albert Einstein? What he says is that it's not that I'm so smart, he says. It's just that they stay with the problems longer. And it's so beautiful. And I was so lucky, I'm working with the Abel Prize. In Norway, it's the Mathematical Nobel Prize. And I met many of those that had gained their prize. And one of them said, when I went to school, the teacher thought I was slow. Because he usually give some task, and the main thing was to answer really quick. But I never answer quick, because when he asked a simple question, and say as simple as 5 plus 7, my thoughts went everywhere. It could be this, it could be this, it could be this. And he was in his mind thinking of all these possible solutions and how he can do this simple calculation. But some of his students said, And the teacher said, oh, that's a clever student. But it doesn't necessarily is like that. Some of the students that use long time can be the most mathematical gifted child you have. You never practice in the theater and the drama that you are the skeptical one, you are the curious one, to train them into be kind of asking questions also in math lessons. So the students should argue for their own solution and procedures. They should understand a mathematical reasoning. They should evaluate the validity of processes and procedures and results. And they take advantage of other people's idea and I think this one arguments. I want to close my talk about mathematics and how we can connect to how important it is with drama and use different ways of let them learn and have the joy of this beautiful subject that mathematics is. But we need to go away from this. This is how it's done, and if you don't fix it, you are not good enough. That's create fear, anxiousness, and they hate math. And I meet so many people that they said math was not my subject. Actually, I hated it. So we need to understand it's another way to this beautiful universe. And I want to close it with a saying from China that says, the best teachers are those who show you where to look, but don't tell you the answer. Thank you.
Thank you very much, Muna, and maybe you have questions?
Yes.
I would like to let 5
We have
minutes.
time, yes, we have. 10
Okay,
minutes.
if
they have.
they have questions.
Maybe we are ready for a break.
But maybe we'll be later.
Excuse me, what is your name again, please?
Mm?
What's your name?
It's Mona Rosseland.
And where are you from?
I'm from Bergen in Norway.
Okay.
Yeah.
I used to consult the staff body in Bergen, and the biggest problem I had was explaining to the
Do you want to use the
mathematical problems. So I draw pictures for them, things like that.
Yeah.
It's just tremendous what you said. Well done. I'm glad I came. Thank you very much.
We had a long way to go. I'm not saying this is how it is. This is how we want it to be. Okay? Some of the teachers are there already, so we are on the way.
The word you were looking for was euphoric.
Hmm?
The word you were looking for was euphoric. I think.
Yeah.
It was a euphoric experience. Thank you.
Yeah.
So you mentioned that the Norwegians are looking into the Finnish curriculum. What's the difference between the Finnish and Singapore that you just showed us?
I think there are more similarities than its differences, but the Finnish curriculum is new. They haven't changed their curriculum for over 20 years, and the Finnish school has been really traditional. You have the math, you have the social studies, but now they are changing that to look more, they work more with projects like sustainability, with the environment. So they work with big projects that they put all the subjects into and to this huge project, and they work together and use the different subjects to solve a bigger problem. They don't do it all the time, but they emphasize more to this, connect the subjects together. And they are changing the way they are teaching. Instead of standing in front of the scene and tell the children. In Singapore, they also work together. The children are sitting in groups, discussing, and the teacher are not like in Norway. You know the math classroom? The students raise their hand and we are running. Well, what they do in Singapore, they place the children together, maybe in big groups, like 5, and they are not allowed to raise their hand. before nobody at the group are able to answer the question. So the teacher are not running. He is sitting because he goes quietly from the group to the group, and it's not silent in Singapore. It's noisy. It's da, 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 but it's a good noise. They're discussing mathematics, so they are not. So it was completely different than I thought when I came there. But of course, it's differences in Singapore also. Maybe somebody have been to a more traditional school, but the school I was visiting, it was really cooperating, and that's what we are trying to accomplish in Norway as well. Try, because some of the students that are raising their hands are the girls. And I said, oh, these awful girls, don't go to them, because they don't need help. They do it, what they are looking for is confirmation. Well, okay, you thought right, this was the right way to do it. They are not actually in trouble, but they want you to come and say, you are good, you are on the right way. They need to be more independent. And some of the boys that are not raising their hands, they are the ones you should approach a lot more than you do. Because they are hiding. They don't want to show anybody that they don't understand. So they don't raise their hands. Yeah.
So you could approach you answer maybe no questions during the coffee break.
Yeah, and we will meet together after the